Okay, so 12.5 is going to be the last section we use SOHCAHTOA, with right triangle trigonometry, along with, so you're going to have two things you're going to do. One is going to be to solve the different pieces of a triangle. So that's this first example. And the other is going to be to read a word problem, set up a diagram, it's a right triangle, and then you're going to solve based on your diagram and what the missing information is. So this first diagram, we've been given this length AC, which is 50. We've been given this angle, which is 36 degrees. So we need to find the measure of angle A. That's part of the missing information. Well, that's easy because 36 degrees and this angle here, angle A, need to be complementary. So subtract 36 from 90 degrees, you get 54, so you're done there. The second thing you need to do is find the measure of C and the length of A. So how do you do that? You have to use sine, cosine, or tangent. Always try to use the given information. So you have 36 degrees, you have 50, so you have to use that given information. So if we want to find C, well, this is opposite, this is hypotenuse, so I have to use sine. Sine of 36 degrees equals opposite divided by hypotenuse. How do I isolate my C? Well, it's a proportion. So what can I do with my C and my sine of 36? I can just switch places. You might be asking yourself why? Well, right, you just multiply by C here, multiply by C here, so you get C times sine of 36 degrees equals 50, divide by sine of 36, divide by sine of 36. So C equals 50 divided by sine of 36. You just switch those places. So now you take your calculator, you do 50 divided by sine of 36. So C equals 85.1. It says round to one decimal place, so there we have it. The last thing I need to do is find letter A. Well, let's go back to my statement that said you should use the given information. Don't use this rounded decimal because that's going to potentially make your letter A inaccurate. So instead, say to yourself, okay, if I want to use 36 degrees, what trig function relates 50 and A? Or you could use the 54 degrees because that's going to be accurate as well. So obviously it has to be a tangent. So tangent of 36 degrees equals 50, opposite over adjacent. What do? I swap tangent of 36 and 50. So I get 50 divided by tan of 36. Sorry, I'm doing this on my calculator myself. So A equals 17.2 when I round it to one decimal place. So the measure of angle A is 54 degrees, the side length of C is 85.1, and side length of A is 17.2. You could also check this if you have time by using the Pythagorean theorem. Is 50 squared plus 17.2 squared equal to 85.1 squared? You could just do a quick check. Okay, moving on to two new definitions, or possibly not because you should have heard these in geometry. We have our angle of depression and we have our angle of elevation. So think of it in terms, if you're up here in an airplane and you're looking down at someone down here on the ground. So from looking straight ahead, this is parallel to this person's view if you're both looking straight ahead. So when you look down on someone, that is the angle of depression. If you're down here and you're looking straight ahead and then you tilt your chin to look up, that's the angle of elevation. What do we know from our geometry days? If these are parallel, then these are alternate interior angles, and alternate interior angles are congruent. So what is true about alpha and beta? That these two angles are congruent to each other. Angle of elevation, angle of depression in the same picture are going to be congruent. Okay, so let's look at our first word problem. That word might come up in one of these word problems. It doesn't in the first one. First, I encourage you to sketch a diagram. It's going to help you visualize what's happening. And then you're going to have to use sine, cosine, or tangent to solve. So it says a camping tent is supported by a rope stretched between two trees at a height of 210 centimeters. So I know that sounds strange. I've never seen a camping tent hitched up like this, but this is the scenario it's describing. Here's a tree, here's a rope that's pulling up the center of the tent. What do we know about tents? Hopefully you know that they're isosceles triangles, this opening right here. And it says that the angle that the tent makes with level ground is 55 degrees. So these two angles are 55 degrees. The height is 210. I'm trying to find how wide it is at the bottom. So I want to find this entire distance. But what are you going to do? Well, you have sine of 55, or sorry, some kind of trig function of 55. You have 210, and you've got to find only half of it, right? And then you're going to double that value. So this is 210, which is opposite. This red part is adjacent, so it's tangent of 55 degrees equals opposite over adjacent. Let's call this part y. So what do we do in order to solve for y? Remember, we just swap tan of 55 and y. These two just switch places. Whenever your variable's in the denominator, just swap it with the other side. So what do? We take our calculator, 210 divided by tan of 55. We get 147.04 blah, blah, blah. That's not the correct answer. We have to double y in order to get x. So I'm going to multiply that answer by 2. So the distance between that gap is about 294.1, go back and look, centimeters. Or you could say about 2.9 meters. So rounding to the nearest tenth, usually that's good enough. Okay, let's look at the next one. I'll do the next one with you, and then you'll do number 3 on your own, and you can check it with me later. Okay, so I've already drawn the triangle, but you should try and see if this makes sense, or try to draw one on your own. But it says 2 observers 1,600 meters apart, so we have this observer here and this observer here. Their total distance between them is 1,600 meters. So 2 observers 1,600 meters apart on a straight, flat road. Measure the angles of elevation of a helicopter hovering over the road between them. So here's the helicopter up here between them. If the angles of elevation are 32 degrees and 50.5 degrees, how high is the helicopter? So I'm trying to find y right here. And I have this angle of elevation was 32 degrees, and this angle of elevation is 50.5 degrees. And obviously, because those angles of elevation are different, this is not an isosceles triangle. Therefore, when we draw this altitude down to get the height that the helicopter is away from the ground, we don't know this length. We know the whole entire length is 1,600, so I need to call one of the lengths x, and the other length then is 1,600 minus x. Now we're trying to relate y and this part to each other, so once again, which trig function are we going to use? We're going to use tangent. So if I'm looking at my left triangle right here, I have tangent of 32 degrees equals opposite, which is y, over adjacent, which is 1,600 minus x. And then if I look at my triangle on the right, I have tangent of 50.5 degrees equals opposite over adjacent, y over x. Now what am I trying to find? I'm trying to find y. So that means I should technically solve for x in one of these problems and replace it in the problem. But you could solve for y. That's going to be a lot easier. Set them equal to each other and go back and substitute in. So actually, solving for y is way easier, so I'd recommend you do that first. So go ahead and solve for y for each of them. So in order to solve for y, we're going to multiply tan of 32 times 1,600 minus x. On this one on the right-hand side, in order to solve for y, we're going to multiply tan of 50.5 times x. And then we can set these equal to each other because they both equal y. So now I have tan of 32 times 1,600 minus x equals tan of 50.5. So I have to distribute this through here, so that's 1,600 times tan of 32 minus tan of 32x, and that equals tan of 50.5 times x. Sorry, I forgot my x here. So obviously I have to combine my like terms, so I have to combine these x's with each other. So I'm going to add tan of 32 times x. So I'm going to add tan of 32 times x. So now you just have to punch all of this into your calculator. So literally punch 1600 times tan of 32. So when I punched 1600 times tan of 32, I got 999.79099631. And then here, I'm going to do tan of 50.5 plus tan of 32. So tan of 50.5 plus tan of 32. So you should have gotten 1.837966356x. So now what do I do to both sides? I divide each side by 1.8, etc. So I do 999.790, blah, 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 blah. And I get somewhere around 543. So 543.97, somewhere around there. But remember, we didn't want x, we want y. So we have to go back and substitute it in. And this is by far the easiest one to substitute in. I'm just going to put my x here. Y equals tan of 50 times that answer. So take this answer in your calculator, multiply it by tan of 50.5. And so x is about, or sorry, not x, y, the height that the helicopter is above the ground is about 659.9 meters. And there you have it. Go back, double check. Yes, it is meters. So it's about 659.9. Okay, now that you've seen how we set this up and see how you have two variables and you have to solve for one of them and substitute in, you're going to do the same thing for this third one. So number 3, it says a sailor sights both the bottom and top of a lighthouse that is 20 meters high and standing on the edge of a cliff. The two angles of elevation are 35 degrees and 42 degrees. To the nearest tenth of a meter, how far is the boat from the cliff? Okay, so we have this boat over here. All right, so this is my boat, and this right here is my cliff. Here's the lighthouse sitting on top of the cliff. It says the lighthouse is 20 meters high. That's the height of the lighthouse, just this black part right here. But if I'm on the boat, I look up 35 degrees to see the bottom of the lighthouse, and then I look up a total of 42 degrees to see the top of the lighthouse. So this is just a 7-degree difference right there. So go ahead, set up your two problems. This is obviously where the right angle is, right there. Set up your two problems and try to solve. Pause and try that on your own. Okay, so you should have gotten tan of 35 equals opposite over adjacent, y divided by x. Tan of 42 equals opposite. Well, this time my opposite is 20 plus y. So I have y plus 20 or 20 plus y divided by x. I solve for y, multiply by x, solve for y. First I have to multiply by x, and then I have to subtract 20. So y equals x times tan of 42 minus 20. I set these two equations equal to each other, so right here, set them equal to each other. I have to isolate my x's, so I have to subtract tan of 42 times x, subtract tan of 42 times x. Just punch into your calculator. Tan of 35 minus tan of 42. You should get negative 0.200196506.1, and that equals negative 20. So now I have to divide negative 20 by this big long decimal, and you should have gotten approximately 99.9 meters. So if you didn't get that, check your calculator work, or come ask me, or ask someone around you if you can, and hopefully you'll be able to figure out where your mistake is. Recognize that your calculator doesn't always put in parentheses for you. You need to end your parentheses. It usually opens it, so you might have made a mistake with that. And then, of course, make sure your calculator's in degree mode. So that's it. Get started on your homework, and I'll see you next class. Bye.